Now see here half-life. So half-life time of the radioactive materials or the radioactive elements. See here this graph. On this here the y-axis I have taken number of atoms, on the x-axis I have taken time t. When this radioactive disintegrate, number of atoms keeps on reducing and it will become 0 after at the infinite time. So that is why this graph is not joined here. Now at certain time, when the number of atoms reduces to n naught by 2, that time is known as half-life. So corresponding time which is required, actually the time required to decay the radioactive element to half of its initial original number present in the sample is known as half-life. So half-life is represented by T half like this. Now we can solve it. We can take the mathematical expression for this. Now we know it, n is equal to n naught e raised to power minus lambda t, where n is the number of atoms present in the sample at any time t and n naught is the number of atoms present in the sample initially at t is equal to 0. So if you are taking n is equal to n naught upon 2 and then t is equal to t half, we can write n naught upon 2 is equal to n naught e raised to power minus lambda t half. This and this will get cancelled. Here is 1 upon 2 is equal to e raised to power minus lambda t half. We can write 2 is equal to e raised to power lambda t half. We can take log to the both the sides here. So when we are going to take log 2 of this equation, we will be getting log to base e here, that is 2 is equal to lambda t half log e to base e. This is equal to 1. So we can convert into the log to the base 10. So that can be written 2.3026 log of 2 here lambda t half. Now we can write in this case, its value is given here 3026 into 0.3010, that we can say into the in log table, that is lambda t half. So we can write lambda t half is equal to 0.6931, or we can write t half is equal to 0.6931 divided by lambda. So this is the expression for the half-life of the radioactive element. So we have got this expression, T half is equal to 0.6931 upon lambda. Now we can get another expression for this half-life. So we can go ahead with this part. We can take, if the anything is here has got the initial number of atoms present, that is n naught. When it reduces to this is n naught by 2, the half-life is T1 by 2. This is the first half-life. In the next half-life, it becomes n naught by 4, that is another half-life. It keeps on going like this. So we can write at any time, that is n naught upon into 1 upon 2 raised to power n, where n is known as number of half-lives. N can be written total time divided by half-life. So n can be written, this is here. So this is also the expression for the half-life of the radioactive element.